Good afternoon, all. Hope my mind map is visible to all. So, in today's class, we are going to see about another algorithm called decision tree algorithm, and the data set which we are going to use is called the iris data set. So, we have already seen about the iris data set, right? So, what are all the classification we had in iris? We'll be having three different classification will be there based on their leaf petal and width and petal length will be there, and sepal length and sepal width. Three different categories of flowers are there, and their names are virginica, versicolor, and then setosa, right? So those data set we are going to take, and from the data set we are going to apply the decision tree algorithm, and we are going to find how much it is predicting the value. Okay, so let us go into the. So we are going to predict. So in our model, we are going to predict what species it is based on the shape which we are passing. Okay, and the collecting data set. Here, we are not going to use any external CSV file, whereas this iris dataset by default available in the scikit-learn itself. So directly we will be importing the dataset. So if we check inside the dataset means we will be having 150 into 4 numpy.nd array. It is nothing but 150 rows into 4 columns will be there. So those 4 columns are nothing but sepal length, sepal width, and then petal length and petal width. Okay, and the output will be separately given, and we are having three type of flavor iris varieties here. So one is a setosa, and the second one is versicolor, and third one is virginica. Okay, so in the iris is genuinely of 260 to 300 species of flower in plant is there, but in that only three types we are taking. Okay, so if you check the summary of our data set means in the data part only the input will be given separately, and in the target we are having what category it belongs to. So it will be given in the format of 0, 1, 2. Okay, so 0 means first type setosa, 1 means versicolor, and 2 means virginica. So like that they have created their target value, which is the output value. Separately we will use it, right? Then in the fourth step, we will be segregating the data set into X and Y part. Here no splitting is going to happen. So directly we can convert X is equal to PD dot data frame. So data set dot data. So this data set is nothing but the variable name which we have created. And in this data variable only, we will pass the iris data set from the sklearn. Okay. Then columns we are specifying the data dot feature names. Okay, so here the syntax is changing. Normal syntax we are not doing, right? So data set dot data as an input, and the columns we will give data dot feature underscore name. It consists of the names, and in the y for the output we will take data set dot target. Okay, all this predefined and available in the scikit-learn itself. Only we are going to import it. For X, we are converting the data into a data frame format. Okay, that is the difference. Once we have splitted the data into X and Y, input and output, then we will try to split the data set into train and testing part. So this also we are doing it for very long time, right? We will be splitting X, Y, and then text size will be giving 25% for testing. Okay, and then random state we are giving it as 0. Okay. So now we will directly see the algorithm, decision tree algorithm. So first of all, there will be one question like why we need to use decision tree? Why not other programming language? When it comes to the machine learning, we are having various algorithm, right? So it is the choosing the best algorithm depends upon the data set and what type of problem you are mainly trying to solve using the machine learning model. Okay, so when it comes to a decision tree, there is two reasons for choosing the decision tree. So first reason is decision tree usually mimic the human thinking ability. So how human will think, okay, this happen means I will do this, otherwise I will do that. Likewise, we will have some alternate options, right? So here also in decision tree, based on the user's decision, okay, based on the inputs it is collecting, it will change its decision. So it will be very easy for a human to understand this algorithm. Okay, and the second thing is the logic behind this decision tree can be easily understood because it will be like a tree-like structure. Okay, that is why we are calling it as a decision tree. So how tree will be there? In the top, we will have some less option. I mean, actual tree if you are taking means uh, what bottom side we will have more branches when we compare to the upper area, right? Similar way it will start from one root node. Just a minute. Okay, so here if you see means, so we are having some root node, then it is dividing into further subcategories, then later on those subcategories are getting divided into multiple parts. So like this only our decision tree algorithm is going to be there. So this is the reason they are calling it as tree like structure. Okay, so one by one we will see. So when it comes to the definition, tree structured classifier, we can use it for classification as well as regression type of problem also. Okay, so data continuously splitted according to the certain parameter. So it will start with the entire data set. Then the entire data set will be divided into two or more halves. So each subset will be again divided into further subcategory until it reaches a point where it cannot be subdivided. It will create that much branches. Okay, so it is a graphical representation for getting all the possible solution to a problem. So decision based on given condition. Okay, based on the condition, our decision or the question which is going to ask also will change in our decision tree. Okay, for example, you are thinking like want to have a ice cream. Okay, the first question you will be asking to yourself is whether it is a sunny day or not. Okay, if I say it is a sunny day, then whether you want to go outside or buy ice cream to the home, okay, order the ice cream or not. So if the shop is very nearby, then you will be decide that okay, I can go and buy the ice cream. If this shop is very far from your place, then you will decide to order the ice cream, right? Similarly, based on the condition, our output also will change. So each sub condition it will ask. So every condition it is satisfying means as a end result you will be getting, since it is a classification type of problem means we know, right? Yes or no, like that we will get. So whether I have to buy this or order this, or do you have to buy or not to buy. So those kind of decision I can easily able to make using this decision tree algorithm. So as I told, it uses classification as well as regression tree algorithm. Okay, then let us see what are all the elements present in our decision tree. So first we will call it as nodes, then branches, and then leaf node. Okay, so nodes means nothing but the features. So what are all the features contained in our data set? Those are known as our nodes. Okay, so when it comes to the branches, Every time it is making some decision, right? Creating one new branch. Here in this diagram, if you see means can able to see. Every time one branch is created, one decision node has been created, right? The main node is our feature. From that root node, we can also call it as a root node. So root node is the form where the decision tree starts. Okay, it represents the entire data set, which will be further getting divided into two or more homogeneous data set. Okay, and when it comes to the leaf node, okay, that is going to be our final output node. So in this diagram, if you see means that is going to be the final output, which will represent as I have given an example, right? In this example, here this leaf node, the first leaf node may be saying that okay, you can order the ice cream, or in the second leaf node may be saying you can buy the ice cream. Likewise, it varies for different leaf nodes. Okay. So simply we can say leaf node as result or the output which you are going to see. Branch nodes are nothing but the sub nodes created, and the node is nothing but the features we are having. Okay. Then, so hope it is clear for you all. So root node means single node will be there. From that sub nodes are created. So sub node entirely we call along with the leaf node we call it as sub tree. Okay, or we can call it as a branch. Okay. So let us see some terminologies. So just now only I have told root node is going to be the start of our decision tree node. It contains all our entire data set. Here, based on the entropy, so this is going to be the formula, the probability of yes into the log of probability of yes plus probability of no into log of probability of no. So this based on this only the entropy will be further created. Okay, so it will uses the measure of impurity. Okay, how much impurity data which is present in our data set, based on that it will split that. Okay, complete data is there. If I want to divide into two half means I should have some logic, right? This and all comes under the left node, this comes under the right node, so those will be splitted based on this condition only. Okay. So how they are deciding is if the number of yes is equal to the number of no, okay, both become equal, then we will say the entropy is 1. If it has all yeses or all nos, then the entropy will become 0. It is similar like the probability, checking the probability. So it will always range from 0 to 1. Okay, so based on the highest entropy, more entropy, it will get splitted. So if I'm splitting into two of means it can be of 0.5, 0.5, or one may be having 0.6 means other will be having 0.4. Like that, the splitting will be happen. All the S's will be in one part means all the no's will be in another part. So based on that only splitting will happen. Okay. So another one thing we will check is information gain. Okay, mostly we will be using the entropy for finding the splitting cases. Okay, whether the entropy is high means it will go in one direction, if entropy is low means it will go in another direction. Okay, so yes or no, same scenario again, I'm coming to the same scenario. um, Ice cream scenario. So first you have decided to eat the ice cream. So first question I'm asking whether it is a sunny day or not, right? So user is giving input as yes. So when I got the yes, the entropy will be 1, right? So which part is having that particular entropy? So that direction it will start moving. If I say it is not a sunny day, then again it may be asking whether it is a rainy day or not. Okay, I'm saying yes, it is a rainy day. So like that, my based on my decision, based on the input of the user, it will change its question and it will change its the decision. Okay, then leaf node, the final output node. Then we are having the splitting. So the process of dividing the decision node or the root node, we call it as splitting. Okay, splitting one node into sub nodes or sub tree categories. Okay, then we are having branch. Okay, so tree formed by the splitting is known as a branch. Okay, so here in this diagram, if you see, means each time two branches are created. Okay, from the root node, two branch created, and from this first decision node, I mean, in the right hand side, if you say, means it will be ending with one, two leaf nodes. Whereas when you come to this particular decision node, it is splitted into two. One is leaf node, and another one decision node has been created. So from the decision node, at the end of we are getting a two leaf nodes. Okay, mostly these two leaf nodes will be of opposite. If first leaf node is saying yes, means second leaf node will be saying no. Like that only it will be splitted. Okay. Then pruning. So it is a process of removing unwanted branches. So we can create n number of branches, right? But all branches may not be useful for us. So in that case, we have to will be removing some branches to increase our efficiency. So those branches, the process is known as pruning. So reducing the unwanted branches to increase our efficiency. Okay. In other algorithm, we used to say, right, hyper tuning and all. Same case here also happen. Each time it will try to tune our algorithm. Okay, whether this entropy is giving. I mean, when I'm creating multiple sub branches, sometimes it will get stuck in one point, right? Further questions may not be asked. So those type of branches can be removed. Okay, like we can say unfinished branch or anything. Okay. Then we will have child node. So nodes other than the parent node are called as child node. Okay. So here parent node means the root node. So except the root node, all are nothing but the child node. Then what are all the tuning parameter we will use? So here we will check for the attribute selection measure. ASM we will say. Okay. So in this ASM itself, we are having so many things like information gain is there, Gini index is there, okay, size square is there, and reduction in variance is there. By default, uh, in our algorithm, we will have this Gini index method. Okay, let us see what this Gini index method. So it is nothing but measuring of the impurity or purity used while creating a decision tree in the cart. Okay, cart is nothing but the entire thing. Okay, so these attribute will have a lower Gini index, should be preferred as a compared to the high Gini index. So when it comes to entropy, it should have a higher entropy, whereas when it comes to the Gini index, it should have lesser Gini index. Okay, so then only it will choose that path. Okay, Gini for the Gini impurity and entropy for the information gain. Okay, so where if you are using Gini means it will check for impurity. When you are using entropy means we have to check for the information gain. Okay, so what does information gain means? So we have seen one formula for entropy, right? Here the formula is entropy of S minus weightage, I mean weighted average into entropy of each feature. So in our case, we are having three. How many features we are having? Four features we are having, right? Sepal length, sepal width, petal length, petal width. So each weightage will be calculated. So in the end, we are getting some output, right? So that is known as the information gain. So measuring the reduction in the entropy. Okay, decides which attribute should be selected as decision node. So here we are having less features. So mostly all columns will be selected for the decision node. Okay, in case if you are having a various columns means in that which is very specific column needed for the entropy gain or the information gain, those attribute alone it will take. Okay, so remaining two and all we will not be using it often. Okay, by default Gini index we will go for, otherwise we will go for the entropy method. Okay, so how it is actually works, this decision tree, how it is work is first it will begin with the root node. Okay, we are seeing on root node, right? It will begin with root node. We can simply call it as R. Okay, in short, I'm saying it as R. Then what it will do is based on the attribute selection measure ASM we have seen, right? So based on this method, it will try to find the best attribute. So as a second step. Then in the third step, what it will do is it will divide the data set into data set here is R, right? So that will be divided into subset possibility of getting best attributes. So that we can say it as third step. In the fourth step, what it will do is it will try to create our decision node. Okay, so it will create a decision node. That decision node will have a best attribute. Okay, here to splitting it is making means in one decision node yes part will be there means in another decision node y part will be there, I'm sorry, no part will be there. Then this process will be repeated, the step 5 process, dividing the decision node into sub nodes or converting into a leaf node process will continues until it reaches a stage where you cannot further proceed or further classify the node. So those nodes only we are calling it as a leaf node. Okay, for another example, if you want me to give means, suppose consider one candidate is there, and for that particular candidate, one job offer has been given. Okay, and we have to decide whether the particular person has to take the offer or not. Okay, so what you will do? What are the scenario you will check for? Whether can I say you will check whether they are paying very high salary or not. That you will check. Then second scenario is whether the office is very far or near. In case you are saying the office is very far, then next question you will have is whether they will provide cab facility or not. Okay, if I go further means you will be asking whether 5 days working days or 6 days working days. So many criteria we will be checking, right? Based on all this scenario, we will be deciding whether we have to take this job or not. Same here also, but it will start with in which question you have to start, whether you have to start with whether the office is near to my place or not, or you want to ask whether cab provided by the office or not. Those details we need to check, right? So in our case, first we can ask about the salary, whether they are paying the expected salary or not. For example, my expected salary is 50,000 per month. Okay, and if they are paying only 30,000 or 20,000 means what you will say, okay, they are not paying much, so I can decline the offer. So simple, one part it will be declining stage. Whereas if they are ready to pay 50,000 per month, then next question you will be asking us whether the office is very near to my home or very far. So if they are saying very far from your home, then you can ask okay, still you want to consider they are paying 50,000, right? So one condition has been satisfied. So you are deciding, you will be asking next question. Okay, if it is farther means okay, but whether they are providing cab facility or not. If they are not providing cab facility, then you will be calculating okay, petrol charges, other travel allowance and all you will consider, and you may reject the offer. Whereas if they are saying okay, we will provide cab facility, and then office is very near to my home, and then they are paying the expected salary, then what you will do? You will ready to take the offer, job offer, right? So this is how our decision tree will work. Okay. Then another one method is maximum depth. So one method we have seen is attribute selection measure we have seen. Another method is maximum depth. Here by default it will go to the top, how many branches it can able to create, it can able to do. Otherwise we can also control it. Okay, so default it is given as none, so maximum depth of the tree it will take. If none, then the nodes are expanded until all the leaves are pure. Okay, but all the cases we cannot expect a pure data, right? Sometimes you have to process with an impure data also. So if you are going for the maximum depth method, means we have to specify the how much depth you want to go. So depth here is, for example, in this diagram itself, if I ask how what is the depth here given is, we can say 2, right? So it has gone 2 stages. In the third stage we got the leaf node. Maximum, at maximum it has been splitted into 2 subcategories. So those we can specify. Okay, but we may not know, right, which uh, depth value we have to give. Exact value we will not know. So here what we will do is, like what we have done for the KNN algorithm, we found the k nearest, I mean very k value which is having the very less mean error, so that value we have passed, right? Similarly here also we will do some matplotlib. Using the matplotlib we will try to plot the graph, and then we will find the maximum depth where we can go. Okay, so that maximum depth value we can give to the algorithm for further process. Okay, then once you have done the maximum depth method, you can start building your decision tree. Okay, so as I told, this is how it will look. So here also another one example has been given. See, is a person fit? So this is what you want to predict. Okay, and the first question they have asked is age is less than 30. Yes or no kind of question only, right? So I am saying yes, age is less than 30. Then the next question is eats a lot of pizza. So next question they are asking whether the person will eat more pizza or not. If I say yes means it will return okay, this person is unfit. If I say no means it will say okay, this person is fit. Then in case if in the first condition itself it is becoming false, the age is more than 30, then it will go to the another decision node. So here again it is asking different question, whether this person will exercise in the morning or not. So if I say yes, then it will return me if the person is a fit person. If I say no means okay, age also greater than 30, not doing any exercise, so this person is not a fit person. So like that it will return the output. Okay, so compare the entropy of a data set. So this is the formula. So based on the zero here, why we have given p of 0 plus p of 1 plus p of 2, because we are having three categories, right? So we have to calculate all the probability of getting Setosa plus probability of getting the Virginica and probability of getting the versicolor. We don't choose any node, Aman. It will try to choose from the data set which we have passed, which feature will be correct for our decision node. Okay, we will be using only the end result. Splitting and all we don't do. Okay, internally the algorithm will do all this process. Okay, so then you have asked which node to select as a root node. That we don't know, right? Here in this example also, first they have asked a question as salary, sorry, age, right? Age is less than 30, they have asked. Instead of asking for the age, what if they ask the question eats a lot of pizza or not? We can ask, right? Any question we can ask interchangeably, but as per our algorithm, it has to choose which question will make more sense when asked as a root. Okay, here it is splitting very easy, right? Otherwise, if eats a lot of pizza, I am giving. If I'm saying yes, then I'm asking the question age is less than or 30 means there is a possibility that people comes under less than 30 exercise in the morning also, right? So it will lead to a improper splitting of data. So to avoid that, it will try to iterate over all the questions whichever it can able to ask, and it will try to find the best fit for our model. Okay, best fit in this case, which question should be asked first? Okay, which feature should be checked first? Like that, it will be considered. So in this scenario, age will be checked first. Then only whether this person will eat pizza or not, exercise or not will be considered. Okay. So as I told, so it will calculate the entropy and identify the maximum entropy. Okay, so when it comes to entropy means we will go for the maximum for which the feature that is going to be the root node. Okay, so what it will do, it will check for all the features. Okay, all the features it will check and find the entropy process. Okay, and then it will decide which entropy is more for which feature, and that feature it will take it as a root node. Okay, same process will be continued for all other sub branches also. Okay, so for assumption, if I take in the top, what we will have is highest entropy. For example, 1.5 like that is there means it will be further splitted into two half. So in one part, you may be having like 4.5 is there and remaining something is there. Okay, leaf node, final leaf node will have a entropy of 0. Okay, if it is a no. And if it is a yes means you will be having entropy of 1. So until it comes to 0 or 1, the process will be continued. Okay. So as I told, to find the best maximum fit value. So we don't know, right, which will be the best maximum fit for our model. So we will be using the matplotlib to plot the values and we will take. So here if you see means after 3 all are having the same score. See, in the x-axis we are giving the predict and in the y-axis we are trying to predict the score for those splitting. Okay, so maximum depth is 3. So even if you are giving more than 3 also you are going to get same output only. Okay, the score is more than 95 percentage, so you can easily go for the number 3. So maximum depth you can give 3 for anything. If you are giving also same output only you are going to get. Okay, so using the range of maximum red. So this how you will decide randomly. You will, I mean, as a range you will be giving from 1 to 10. If you are giving means from there you can able to see. In case up to 10 you have checked and you have not achieved any good result means you can increase to 20, 30 like that also you can check until you get a best score. Okay, so we can obtain with the maximum depth value which will perform very well in our model. Okay, then once we got the maximum depth value, after passing into the algorithm we will start our training process. Okay, by giving the x train and y train, then we will start predicting for the testing test data set. So we have already split it into two halves, right? 25 percentage of the data we have taken for testing purpose. So those testing data we will compare, then accuracy score, what confusion matrix, all this are we will be find, right? Validating accuracy score we will find for our model. Okay, so let us see the coding part. Okay, hope my Jupyter notebook is visible to you all. So here externally I'm not going to import any CSV file. So predefined data set only I'm going to use. So no need of giving pandas and numpy. Okay, maybe if we are using it later means we can import those panda and matplotlib. Okay, as of now I'm just giving the data set alone. Okay, so where you will get the data set of from the scikit-learn. So we will get from sklearn dot datasets, right? So previously also I think we have taken for hand recognition, digit recognition dataset we have taken, right? Load digit the. So similarly from, okay. So from sklearn dot dataset import. So this dataset name is known as load iris. Okay. So many dataset is there. Previously we have seen load underscore digits, right? So this alone I'm importing for right now. Later on, if I need means we can import the pandas and numpy, matplotlib, everything. Now we have to pass the loaded value to a data variable, right? So I'm just creating a data set and then passing the load iris. Okay. So now I can go and summarize my data set and can see what are all the data values I'm having, what are the target values I'm having, and then what is the shape of my data set. So those details I can able to check, right? So I can simply give data set dot data, then data set dot target. So this is my data which consists of 4 columns. Okay, and then so this is my target value. Zero, all zero represent Setosa and first one represent Virginica and two represent versicolor. Okay. So if I check for the shape, then I will be getting I think 120 or something we have seen in the mind map, right? So that value we will get. Data dot shape. Okay. So 150 is there. Evenly divided. I think 50, 50, 50. It has been divided. Okay. So inputs are going to be uh, sepal length, sepal width, and then petal length and petal width. Outputs are going to be Setosa, versicolor, and then Virginica. Okay. Then we have to segregate the data set into X and Y. So we can easily do also instead of going for PD dot data transfer all those things, we can directly give X is equal to data set dot data. Okay, and Y is equal to dataset dot target. Otherwise I will print and show also. Okay, same value which we have checked previously, right? Same only it is going to come. So dataset dot target. Okay, then I'm going to split the dataset into train and test part. So this also we have already seen sklearn dot model selection. So from sklearn dot model selection import train test split. Okay, so x train test Void train, void test. Okay, so train test split is there, passing the x and y. Test size I'm giving 0.25, and then random state I'm giving 0. Okay, so after splitting, okay, 75 25, let us see how much it has taken for training and how much it is kept for testing. Sorry, x train. So out of 150, I mean 112 data taken, 112 rows we can say, taken for training purpose, and 38 taken for the testing purpose. Then we have to find the best maximum depth value. So instead of we have already seen in the diagram, but still directly we can go for the training first. Okay, and then we will check the what is going to be my best maximum depth value. Then we will predict and other things. Okay, so training part. So from the training part, from sklearn dot. So for this decision tree, other algorithms which are related to the decision tree type of algorithms, we will be importing it from the tree class. Okay, so from this I'm going to import the decision tree classifier. Okay, sorry, decision tree classifier. See, decision tree regression also is there, and we are going to use decision tree classifier. Okay, so I'm creating one model. So inside the decision tree classifier, okay, here we have to see the parameters. So what are the parameters we have seen? We have talked about the entropy and then maximum depth, right? So I'm here also I'm going to give the entropy. So the parameter name for the entropy is criterion. Okay, so based on which criterion I'm going to create this decision tree. So based on the entropy method. Okay, then maximum depth. Assume that I don't know what is the maximum depth, best maximum depth. So for I'm giving only 2. Okay, and then here in the algorithm also you can give a random state if you want to each time you want to split the data in same. Otherwise you can ignore the random state also. Okay, then I have to fit the dataset into my model. So X train, comma Y train. So decision tree classifier has been created with a criterion of entropy and then maximum depth with 2. Okay, if you are not passing these two information also, it will automatically take one default value. Okay, then based on this model which I have created, based on the entropy and the maximum depth of 2, let us going to predict what how much accuracy it is going to give. Okay, so y predict is equal to model dot predict x test. So test value I'm just passing. So y predict if I put also it is going to be 0, 1 or 2 only. So let us find the accuracy score now. Then we will find the best maximum depth value. Then we will change our model to the maximum depth value, and then we will perform remaining prediction and accuracy, and let us check whether the accuracy is getting increased or not. Okay, so accuracy score if I check means from sklearn dot metrics. So I'm importing the accuracy score and then the confusion matrix. Okay. Mm. So accuracy is going to be accuracy score of y test comma y predict multiplied by 100. Okay. Then we have to give percentage. For confusion matrix, again y test, y predict. Okay, so let us see our model accuracy. So we have got 89% of accuracy and this is our confusion matrix. So here if you see means we are having three value like 3 by 3 matrix like that we have got. Why? Because we are having three classifications, right? Previously and all we had only two classification, so we had only 2 by 2 matrix. So but now we are having 3 by 3 matrix. Okay, so that is why you are having, I mean, now we are having three classifications, so that is why you are getting 3 by 3 matrix. Okay, so let us change, I mean, let us find the best maximum depth value and then we will change our model and then we will try to predict our test data again and then we will check the accuracy whether it is increased or not. Okay, so to know that, first I am going to create an empty list to store all my accuracy value. Okay, this values only I'm going to plot in my graph. Okay, from sklearn. Okay, simply I will just copy paste. So I have already imported this, right? Again, why I am giving in the top means when you are trying to run the program from the top, in between I have skipped this line and then I went to this cell and then only I am running this cell. But when you are running from the top to bottom, that time if this is not defined means this line it will, this cell it will throw the error. So to avoid getting the error only, again also I am giving the same input values. Okay, otherwise no need. Here I'm going to find only the accuracy score. So I'm taking only up to the accuracy score part. Okay. So we know that maximum depth when I give 2 means our score is 89.47 we have got. So similar way we are going to pass different maximum depth value and then we are going to find the accuracy score for those value and we are going to plot it in matplotlib. Okay, similar like KNN method only. So I'm going to put one for loop. So for I in range, so 1 to 10 I'm going to give. Okay. So model is going to be my decision tree classifier. Okay. So I'm not even giving the criterion. So let it take the default everything. Let it take a default except the maximum depth. So instead of giving 2, I will give it as I. So it will check for 1 to 10. Okay, for each iteration. Then model.fit x train comma y train Then we have to predicted score, we need to know actual score, and then accuracy we have to update the score, right? So I'm going to predict. So for prediction, simply I have to give model dot predict the x value. So once model has been created, I will predict with the x value, and then I need to know the score, right? So accuracy score of y test, comma, here I have to give only PRED predict, because here I have given the variable name as predict only, right? So I'm going to compare with this predict statement only. Okay. So that's why I'm giving y underscore test comma predict. Whereas here if you see the syntax means I might have given y underscore predict. Okay, there's a difference. Then this stored value is there, right? The store value. This I will pass it to my list, accuracy list. So simply I can give accuracy dot append the score. So all this I have given inside the loop only. So once the looping process is completed, I want to plot my algorithm, plot my graph. So I have to give plot like plt dot figure. So I'm going to set the size of my graph. So figure size I want to be in 12 comma 6. So width and height I'm just giving, and then I have to plot it. So plt dot plot range. I have to give the range from 1 to 10. Okay, same range which I have given for prediction purpose. Then I have to pass the accuracy, which is nothing but my list, accuracy list. Then color, line style, marker, marker face color, everything we can give as per our convenient. Okay, so simply to get the same output as we have seen in the mind map, we have to give like color is equal to red. Then line style, I want my line style to be dashed. Okay, then marker. So if I give marker means it will point like a O. Then I can give marker face color. Marker face color means inside we will get one color, right? So that is what we call it as marker face color. Okay, it's going lengthy, so I will just split into two off. So marker face color, I can give it as blue. So I like blue. If you want means you can give different color. Then the marker size. So I want it in some bigger size. So I will give it as 10. Okay, and other basic things like we are giving yielding, I mean title to our graph, and then x-axis what should be written and y-axis what should be written. So plt dot title. So it should be written as finding the best maximum depth. The x label I have to give predict. The y label I have to give score. Can say score or accuracy score. Okay, so let me run this and check what output I am getting. Okay, I have made one error. What error? Decision tree classifier observers no predict. Okay, spelling mistake only, so no problem. PREDICT, right? Okay, so same graph which we have seen in the mind map, we got it, and here you can see I have got 89 point something, right? It's an accuracy. So same near to that accuracy I got in the graph also. So from here you can say when I give 3 or more than 3, I will be getting accuracy more than 95 percentage. Okay. So since I know the maximum best depth, I'm going to change it here. Okay, I'm going to give maximum depth as 3, and then I'm going to run this algorithm again. So my model has been changed. So now I'm going to predict it again. Okay, so now if I check my accuracy means see you can able to see 97.36. That much accuracy I have gained in this decision tree algorithm. Okay, so here if you see means very less error only I am getting. Okay, this and all correct values. Okay, and only one place we have got some wrong values. Okay, then if I want to check for a new value, okay, new value I'm passing for all the four uh, features, and then I want to check whether I will get any of the one flower. Okay, so for that to predict new flower type, so what I can give is either I can get it from the user, otherwise simply I will assign some value swpl pw. Okay, this is nothing but sl means settle length, sw means settle width, pl means petal length, pw means petal width. So directly I'm assigning some values. Okay, it is going to be a float value only, so you can assign any value. If you are having doubt what values are I have to give, how do I know means you can check in the data set. We have seen some head and other things, right? So from here you can take any value and you can check. So currently I'm just giving some random values. Okay, so if I give 5.1, 3.5, okay, so like this I'm giving, okay, four values I have given, and then result I'm going to find it by passing it into the model dot predict. Okay, here you know any typecasting, anything, sorry, feature scaling and all I have not done, so no need to worry. Only thing is I have to convert the values into a data frame and I have to pass it into the predict method. Then once the result has been created means I can check my result. So based on the result here, I will not go with the if and else. I have to check two condition. If two condition fail means I will go to the else condition. Okay. So for that, what I have to give? If result is equal to 0, then I will say it is Setosa. Elif, if the result is equal to 1, then I will say it belongs to versicolor. Otherwise, okay, no other option is there. So last option is sorry, just a minute. What that Virginica. Okay, so let us see for the given values, what are values I have given, whether it is saying Setosa or versicolor or Virginica. Okay, so as per my prediction, it is saying it is a Setosa. Okay, if I slightly change the value like okay, instead of giving this value, if I give different value, like instead of giving 5.1, I'm just changing to 5.8, uh, 2.5 or 2.8. Instead of giving 1.4, 5.1. Some values you can take it from the data set also to check whether it is coming properly or not. So now if I run means okay. So I'm getting the Virginica type. So two types we have seen. Like Setosa also I got as one output, Virginica I got as output. So let us change few more values also, and we will find whether I can able to achieve versicolor. So let me keep this to constant 5.1. This alone I'm just changing 2.5. Okay. Let me check. I don't know. I'm not sure whether I will get versicolor. Okay. This also comes under Virginica. Maybe if I reduce few things. Okay. From here you can take any value, and if you are trying means you may be getting some versicolor also as an output. Okay. So up to here it is clear for you all. Very simple concept only we have seen decision tree method. Okay, based on your decision, it is going to change everything. Any doubts? Okay. So in decision tree also we are having some disadvantage also. Okay. Anyways, if you are having advantage means some disadvantage also will be there, right? So some of the disadvantages you may be end up in an overfitting. Okay, so overfitting means in the testing data you may be getting more accuracy, whereas when you are trying to pass some sorry in the training data you will be getting more accuracy, and at the time of testing purpose your accuracy may not be work as expected. Okay, so to resolve this type of problem, so we are having an enhanced version of decision tree and all is there. Okay, like we are having random forest, XGBoost. Those are also similar type of decision tree only. Okay, and if we are going for more classes, okay, I mean two class, three class, okay. If you are going for 10 classes, like for example, digit classification and all is there, right? Likewise, we are having so many classes means splitting will be very difficult in decision tree because the complexity of our algorithm will also increase, right? From one root node, it has to split it into 10 root nodes, so 0 to 9. So 10 root nodes again it has to split. So it will become a big picture, right? A big tree it will become, and it will be very difficult for us also to understand the entropy. Okay, so it will work very fine for few classes. So hope it is clear for you all. And about the registration process, everyone try to complete the student registration by this weekend. Okay. Whoever has done in the previous month, August month, that cannot be considered now. Okay, in the September month, you have to do it again. Okay, only if you are completing only, we will be processed from our side. Once that process completed in this month means, then only you can able to apply for the NSQF examination in upcoming months. Okay, uh, and project also now itself start as I told you, start searching for the objective. Okay, team members you can select, you can do some brainstorming with your team members. Okay, so if you have decided means you can inform to me also, so this topic I have decided. So if any two team members coming with the same project name means I can ask them to change who are coming later. Okay, so thank you all. See you all on tomorrow, Monday. Not tomorrow, Monday.